Hello! Today we continue solving problems on rotational motion and we'll consider the following question. When a car moves along the road, the linear speed at the tops of its wheels is 43 meters per second. What is the linear speed of its axles? B, at the lower part of the wheels. C, points lying on the horizontal line passing through the axles of its wheels. So let's consider the problem and the three questions related to it. We need to find three speeds, so let's denote them as V2, V3, and V4. Considering that we know the speed at the tops of the car wheels, which will be V1, is equal to 43 meters per part. So, let's illustrate on the diagram how these points are positioned and how to connect them. The desired velocities as well as those velocities we already know. We have, let's say, a wheel. That is, the car is moving along the road. Let's consider one of its wheels. It is clear that for the other wheels we will have the same method. We know the speed of the upper points of the wheel data, meaning this is the point that is located here at this moment in time. This will be speed V1. Next is the speed of the wheel's axis, directed horizontally to the right. This will be V2. Next is the point of contact of the wheel, which is its lowest point. Here we are talking about speed V3. And speed V4 refers to the points lying on the horizontal line passing through its axis. So here is our line. Either it's a point or it doesn't matter. Let's consider the point here. And at this point, let's say, we will look for the speed V4. So this is how these points are arranged. The wheel, of course, has a round shape and a certain radius. Well, now it's important to continue the reasoning from a certain standpoint. In other words, we must first demonstrate that this car is moving along the road. And if the wheel moves without slipping, then at any given moment, the point of contact of the wheel with the road is at rest. That is, it is not moving at this moment in time, and therefore immediately. The answer to the question regarding the lowest point, we can immediately say that V3 at this moment in time is 0. If the car is skidding, meaning it is moving, say, forward with slipping, then of course this point will also be moving. However, our situation is without any slipping. The car is moving, so we've resolved the first issue with you. As for other points, let's start from the top point and take a closer look at it. How it will be connected to the central point, that is the axis of this wheel. In this case, the problem can be solved in two ways. Let's consider both methods, and the first one will be calculated based on zero lower point, specifically in terms of speed. The fact is that any point on this wheel is simultaneously involved in two movements. That is, the translational movement of the wheel forward plus its rotational movement. Overlapping each other, these movements create the overall motion of this wheel, specifically its points. And then it turns out that each point, having at least one translational speed directed to the right, is V2. I will also have a rotational speed, which will be directed tangentially to the trajectory at the corresponding point. Here we understand that the movement occurs clockwise, and the rotational speed will be directed in the opposite direction. Let's denote this speed as v with the subscript r. Considering that the final speed of this point relative to the Earth is 0, we can say that v2 and v0 are equal in magnitude to each other in this case. In other words, by summing these two speeds, we ultimately get 0. Where does this lead us? This leads to the fact that we can now view the situation from a higher perspective and consider v1 as the sum of two velocities. We see that v1 is the sum, the linear speed of this car or its axle, and its rotational speed. But considering that these speeds are equal, we can then say that v1 is v2. And from here we can easily find v2. This will be v1 divided by 2. Or accordingly, it turns out, 43 divided by 2. it comes out to 21.5 meters per second. So this will be the speed of the center of this wheel or its axis. So we have found v3, found v2, and now we just need to find point v4, its speed. In this case, we will similarly describe the two speeds at this point. That is, we have speed v2, which is the translational speed, and the rotational speed, directed vertically in this case, that is tangential to the circle at this moment in time. It will be pointing vertically upwards. Then, according to the law of addition of velocities, we understand that the full speed will be composed of these two vectors and will be positioned in this manner. This will be v4. Here we can write down this expression. That is, v4 is v2 plus the rotational speed. And geometrically, we see that we have obtained nothing other than a square, because v2 and the rotational speed are equal to each other. Therefore, our task is to find the diagonal of this square. The diagonal, as you might recall, in a square is determined as the sum of the squares of the legs, taken under the square root. According to the Pythagorean theorem, we can calculate the speed. Or considering that the rotational speed is also equal to v2, we get the square root of 2v2 squared under the root, or v2 times the square root of 2. After the calculation, let's input the value. We get 43 with you. To multiply, we will approximate the square root of 2 as 1.4, and we approximately get a speed value of 61 meters per second. So, that was the first way to solve this problem. The second method is based on a technique called the velocity triangle, and it is related to the instantaneous axis of rotation. That is, in this case, when we hypothetically capture thoughts on this wheel, then we consider its rotation relative to the instantaneous axis of rotation, which is located at this point. That is, the wheel completely turns around it. And then it turns out that, considering the rest of this point, all velocities will fit into a single triangle, the base of which will be the greatest speed, which is the speed at the top point. And all other speeds will fit strictly within this triangle. That is based on the proportionality of speed, linear and angular, which are interconnected through the radius. We will understand that the highest speed is at the point furthest from the axis of rotation, which is the speed at the top of the wheel. And the closer we approach the axis of rotation, the more the speed will decrease accordingly. And here it is evident that, for example, the center of the wheel is twice as close to point O as the top of the wheel. Therefore, the speed at the center will be half. In this way, you can find any point, the speed of any point located on this line. This is another method that can be used in solving such problems. So this concludes our practice session with you. See you in next lessons. Goodbye, everyone.